10.3 is all about simplifying radical expressions. So here we're going to be working with multiplying and dividing rational expressions. When we're multiplying rational expressions, our basic concept of this is we're able to actually multiply the coefficients, 3 and negative 5. And then we're able to multiply the radicals, right? So basically we can just switch all this around. 3 times negative 5 times radical 2 times radical 2. 3 times negative 5 gives us negative 15. Then we have radical 2 times radical 2, which we can sort of treat that here as radical 2 times 2, which is radical 4. And radical 4 is just 2. So all this is really is negative 15 times 2, which simplifies to become negative 30. Now, in addition to multiplying, when we multiply radical times radical, coefficient times coefficient, we can also divide using the same process. Now, this problem here, we have everything underneath one huge radical. So the first step that I would take is to see, okay, well, just if we look at the fraction, so we ignore the radical for just a minute, if we look at the fraction, what can we do? Are we able to reduce anything? Can we cancel anything? And all that great stuff. We have 12 and 49. 12 and 49, those cannot reduce at all. They don't have any common factors, so we leave the coefficients 12 and 49 alone. But then when we take a look at this, we have x to the 5th over x. So basically that means we have 5 x's in the numerator, right? And I'm just going to write this on the side. That means x times x times x times x times x over x. And what happens there, right? Well, we're multiplying in the numerator. We're dividing by that x. So we can actually take this and cancel one of our x's out. And that means all we have left is 4 x's in the numerator, which means we have x to the 4th left in the numerator. So if I just take that and put that back in, 12x to the 4th over 49. Now that we've simplified the fraction completely, now we can go ahead and we can actually give the numerator and the denominator their own radical. So we have the square root of 12x to the 4th over the square root of 49. Well, the square root of 49, that's really nice, right? That just gives us 7. The square root of 12, the square root of 12 times x to the 4th power, oh boy, if I could talk, 12x to the 4th power, well, we would go ahead and we can actually split that up as well. We can split that up into the square root of 12 times the square root of x to the 4th power. The square root of x to the 4th power, we learned earlier, we can go ahead and, actually we can convert this into a rational exponent if we want to, right? We could say x to the power of 4 over 2. 4 divided by 2 just gives us x squared, so all of that just becomes x squared. Then we have the square root of 12. Now, up until this point, we've been able to evenly square root all of our numbers, but we cannot evenly square root 12. So what we want to do is we want to learn how to simplify our radicals. And in order to do that, we want to find a factor or factors of 12 where we can easily take the square root of one of them, evenly take the square root of one of them. So I can recognize, okay, well, my factors of 12, just in general, are 1 and 12, 2 and 6, 3 and 4. I can easily take the square root of 1, and I can evenly take the square root of 4. But if we split this up into 1 times 12, that's really not going to do anything. It's still going to give us a value of 12. So we're not going to use the 1 there. But we are going to use the 3 times 4. And that's how we're going to split up 12. The square root of 4 times 3. Our properties of radicals says that we can take this when we're multiplying a radical. We can give each term its own square root. And then from there, the square root of 4 is 2. The square root of 3 stays as the square root of 3. So we have kind of a lot going on here in our numerator. The 12 became 2 radical 3, or 2 times the square root of 3. The square root of x to the 4th power became x squared, so we're saying this times x squared, and that's all over 7. But we can actually simplify further, and excuse me, excuse me. We want to always have a radical at the end, because this looks kind of weird, number one. But number two, if you don't put this little hook at the end of the radical, it could look like you were just lazy and didn't put the square root over the whole thing. So I'm going to go ahead and just rewrite it as 2x squared radical 3 over 7. There's nothing else to simplify, so that is where we end. Another example that I want to do here is 2f. Okay, so just like when we have, let's see, when we are simplifying underneath a big radical like we did here, we can take this, and if we have the same radical but it's split up, a cube root in the numerator, a cube root in the denominator, what we can do is we can actually give that one big cube root sign, 9x to the 4th power y to the 6th over 72x. And then that way we can simplify the fraction first, which here are 9 over 72. That actually does simplify. Our x to the 4th over x, that also simplifies. So we get x cubed y to the 6th over 8. And now we can simplify our cube root. We can split it up again into the cube root of x cubed y to the 6th over the cube root of 8. We could further split this up into the cube root of x cubed times the cube root of y to the 6th over the cube root of 8, which we can go further, right? The cube root of x cubed is just x. The cube root of y to the 6th is y squared. And the cube root of 8 is 2. Totally simplified. Once again, it does just take practice. Practice, practice, practice in order to get this. And there's not just one way to get to the answer. It's kind of nice because there's multiple ways to get there. It just depends on what you see first.